Number 3, we have a line that's given to us where they have an open dot at the 0, and it's going this way, right? So first off, we have to remember where that arrow is going towards. It's going towards negative infinity. And so it says write the inequalities. So I want x is less than 0. That's my inequality. Okay. And then I want the interval notation, which I'll indicate as I comma or I period n. So we do interval notation reading numbered lines from left to right. So furthest left, so this is left to right. That's how we're going to read it. So we're going from negative infinity. That will always have a soft bracket when it's an infinity, okay? And then we're going to go to 0, and that's also a soft bracket because we did not include it as a solid dot, or we didn't have an equal sign on our inequality. All right? What else did you see on the homework I could help you out with? Yes? 11. Okay. So number 11 says the temperature in a refrigerated truck must be kept at or below. At or below. So it has the word at or below 38 degrees. Okay? Because it says at, that means we include the endpoint. So define the interval, define a variable, so x, write the inequality at or below 38 degrees. Okay, so that's our inequality. And then write it as interval notation. Now, it'd be kind of silly to say we're going to negative infinity as far as temperature goes, but mathematically, technically, if this was on a numbered line, I could go from negative infinity to 38. And 38 has a hard bracket because the word at means we include it. Our inequality would have the equal sign, so we have a hard bracket there. Is that okay? And it is kind of goofy to think that we're going all the way to negative infinity, but mathematically we could say that. Yeah?
You do 8 or 19.
19? Mm-hmm. Yeah. Number 19, we have y plus 3 equals 2y minus 5 plus 10. Well, one thing you have to realize is I don't really have a number sitting out in front. I mean, I guess I do have a 1 in front of both of those parentheses. So if I distribute a 1 over the parentheses, we can just drop the parentheses. And same thing here. I can just drop the parentheses. And then it says solve the following equations. Okay, so that means we want to get y by itself. So if I add those together, I'm going to get 2y plus 3. If I add those together or subtract those, I'm going to get plus 5. And then if I go to start solving it, I can say, okay, I'm going to subtract 2y from both sides. Those cancel and those cancels. And we either figured out one of life's great mysteries, that 3 is equal to 5, or we realize that's absolutely nonsense, so we have no solution. Or we could have the 0 with a diagonal slash through it. Is that right? Yes, ma'am?
You do 13.
13, yeah. Okay, number 13 says a football team scores between 10 and 28 points. So it says we will score between. Okay, so that means we're going to go between 10 and 28 points. Okay, so we can say less than x and less than 28. Okay, we're not including the endpoints. If I wrote this as interval notation, from left to right, 10 comes before 28. So the interval notation would be 10 comma 28. Those are both soft brackets. Please don't confuse that as a point, because sometimes a point would be written in parentheses. Yeah.
You do 15 and 17.
15 and 17, sure. Number 15 says x minus 7 equals negative 5. Okay, so we just want to get x by itself, so I'm going to add 7 to both sides. So negative 5 plus 7 is going to be 2. That one's done. And then 17, 7 over 3x plus 3 over 2 equals 23 over 6. So let's figure out what the smallest number that 3 goes into, 2 goes into, excuse me, and 6 goes into. So if I multiply everything by 6 over 1, because 3 goes into 6, 2 goes into 6, and 6 goes into 6, if I do this, 3 goes into 6 twice, 2 times 7 is 14, so I get 14x, plus 2 goes into 6 3 times 3 is 9, equals 6 goes into itself once, 1 times 23 is 23, and then we can go ahead and solve that. Subtract 9, those cancel, so 14x is equal to 14. Divide each side by 14, so you find that x equals 1. That worked out real nicely. The clearing denominators, something we'll use all along, so you'll start catching on, okay? Yeah. Okay, so like number 11 says, a temperature of a refrigerated truck must be kept at or below. Kept at means it could be that temperature, or below is underneath that temperature. So that would be a hard bracket at the 38 going to. And then the football team says, we scored between. So it doesn't mean you scored 10 points. It means you score more than 10 points. You don't score 28 points. You scored less than that. So it's between there. So it's just kind of looking at the terminology. And those are definitely be ones, when we have a test or quiz, I'll have it typed up and highlight and make sure we feel comfortable with it, okay? Yes, ma'am?
For 13, why would you put a lesser than sign in front of or after?
Okay, so that's a great question. So I think I had this for an answer on 13. Was it something like this I did?
Yeah.
Okay, so let's kind of break this up. This is called a compound inequality. This is a great question, by the way. So it basically means it's two problems. This is one problem, and this is the other problem. Now, I can flip inequalities over as long as I flip the sign over at the same time. So I could change this to that. So x is greater than 10, x is less than 28. But because we know we can flip this over, and then these are the same, means I can put it together. Does that make sense? Cool. Any other questions, my friends? Yeah.
Problem 16.
16.
If you were to would the answer just be 5.5?
Let's see. Sorry.
Make it negative 33 over 6.
Let's see. 33 over 6 sounds good. I know that 3 goes into both top and bottom. 3 goes into that because that's 3 times 2, and that's 3 times 11. So the 3's would cancel out. So I would get x equals negative 11 over 2. I'd keep it as an improper fraction.
You could, yeah.
I mean, you could make it a mixed number, but we're trying to steer you all away from mixed numbers because that's kind of an elementary school scenario.
Well, but 6 goes into that 5.5 times.
It does. 5 and 1/2 is the exact same thing. But we're trying to stay away from mixed numbers. And the reason we stay away from mixed numbers is so that you can identify that as 5 and 1/2. But a lot of times students will write this, which then that starts looking like this. And those are not the same thing. That's why the main reason we stay away from mixed numbers. It becomes just a writing thing. It's kind of like, remember back in elementary school, you had a true-false test? So did any of you ever do this? And you start getting this little curve. So when the teacher's like, it's true. Oh yeah, that's a T. Well, that looks like an F, kinda. Or if they said it's, I marked it true and you marked it false. Oh, that's not that. I just wrote that because I was like nervous. Didn't you ever do that in elementary school? Yeah. This versus this. Okay? This looks like the letter F. I understand, but you remember in elementary, I mean, I don't know, maybe I was the only one that ever argued this. True false test. If I wasn't sure, I would kind of yeah. Yeah. Oh, so you had an F like that and a T like that? Yeah, I mean, it's just all goofy stuff. And then our teachers got wise to it and they said, okay, write the word true, write the word false. Oh, can't get away with the T with the curve at the top to make it look like an F if it needed to be. All right, are we good on the homework? Feel all right? Yes, ma'am. 5? Number 5, x is less than or equal to -7. Says write an inequality in words. Okay. X is less than or equal to -7. And then graph it. Graph it would look like this. If I had a 0 here, I had a -7 here. It's a solid dot on the 7, and it goes this way. It says write an inequality in words. We got it. And then graph. Okay, cool. We got it. Anything else off the homework? I think we did a lot of them. Cool. Are all phones up yonder need to be? Or hiding away, out of sight, out of mind? Sweet. All right, let's go to our notes. I am on notes for number 2. Looks like we're on page 69, I believe. So find... I gotta go back in time a little bit. I think that's it right there. Is that what we have about? Cool. All right. So inequalities, an inequality sign can act like an equal sign. Now, if you just add or subtract things to bring it back and forth, that's totally fine, just like an equal sign. So for the first problem, I'm going to go, well, let's add 5 to both sides to get t is greater than 15. So solve the following inequalities. We have it solved. Graph the answer and write it in interval notation. So if I had a problem like this, I'd have a 0 here, 15 here. Is it an open dot or a closed dot on the 15? Open, because we don't have an equal sign. And we want values greater than that, so it goes this way. So we know that this is going to infinity, right? So if we write it as interval notation, we read the number line from left to right. So it's a soft bracket on the 15 to infinity. And remember, infinity always has a soft bracket on it. Why is it a soft bracket on the 15, though? Because there's no equal sign. It's not a solid dot. Agree? Cool. Feel comfortable with that? So this over here will be the interval notation. Okay. Problem number 2. I have 2 times x. How do I undo 2 times x? Division. Division, right? All right. If you'd like, you can just until you get the book. Cool. So division is going to take place here. So I'm going to divide that by 2, divide that by 2. X is less than what? 2. Yeah, 4 divided by 2 is 2. Okay. All right, so let's write on number line. I got 0, maybe 2 here. Open or close dot on the 2? Open dot. Everyone feel comfortable with that? And I want values less than 2. Less than 2, does it go to the left or go to the right? Left. Good. So we shade it this way. So if it's going to the left, where's that arrow pointing to? Negative infinity. Very good. Now when we write the interval notation, we read our number line from left to right. So we're going from negative infinity, and the infinities, again, always have a soft bracket, which is a parenthesis, and we go to 2. Does 2 have a hard bracket or a soft bracket? Soft. Done. Am I right? So number 3, there looks like there's a little bit more to do. This is a 2-step equation. We have 2 math operations that have to take place to get x by itself. First thing I'm going to do is I'm going to subtract 8 from both sides. So you get 2x is less than or equal to negative 4. 4 minus 8, negative 4, right? And then I'm going to divide both sides by 2. So x is less than or equal to, what's negative 4 over 2? Negative 2. Okay. So I have negative 2 here on the number line. I have 0 here. 0 would be to the right of that. Solid dot or open dot on negative 2? Solid. Why solid? Because it's equal to. I want values less than, so do I shade left or right? Left. Okay. Where does that left arrow point to? Negative infinity. And then from there, we're going to go ahead and write our interval notation from left to right like we read. So we go from negative infinity to negative 2. What kind of bracket on negative 2? Hard or soft? Hard. Why is it a hard bracket? Yeah, there's an equal sign underneath the inequality sign. Agree? Cool. Questions on these, my friends? Yeah. Because I wanted values less than 2. So less than 2 would be negative or 1, 0, negative 1, negative 2, negative 3, all the way to negative infinity. Cool. Any other questions on this page? And again, the interval notation. You look at the number line, you read it from left to right when you make the thing. Left to right, left to right. Okay? And again, the interval notation is used quite often in future math classes. Okay? Sometimes you have something called a piecewise function in other math classes that you actually graph, and you have to make the graph based on that. Interval notation a lot of times falls into something called the domain, and the domain are the x values. These are all terms that you'll see in the future or hear in the future. All right. Let's see. Oh, it's on the page. That's the next part, right? That's down at the bottom. Okay, so these are a little harder ones. Okay? So we definitely have an x on the right side of both of those. Agreed? X is not on both sides, it's just on one side. Agree? All right, so problem number 4, I'm going to do this. I'm going to add 3, add 3. So it gives me 9 is less than or equal to x. Well, that looks a little goofy. So I think a good idea is flip all over. So change this, make it this. Notice I put the x on the left side, the number on the right side. The sign changed direction because we flipped the whole thing over. Okay? Now it just says to write this in interval notation. Just write in interval notation. So I want values that are greater than 9. So we're talking like 10, 11, 12, all the way to what? Positive infinity. So my interval notation is going to go from 9. Why did I have a square bracket on the 9? Because the equal sign's there. So it's going from 9 to infinity. And again, infinity, friends, always has soft bracket or parenthesis. No? Yes? Maybe? Oh, yeah. Looking good. Okay. Problem number 5. What are some suggestions from you to get x by itself? I like that. Minus 18 sounds like a really good idea. Notice I did it from either side of the inequality. That way those cancel. 12 subtract 18 is negative 6, I believe. How would I get x all by itself? Divide by 2. So I'm just bring this over here. So I get -3 is greater than x. Flip everything. Good idea. Flip everything over. So the sign changes directions because I flipped the whole thing over. Okay? So now I want values that are less than -3. So like -4, -5, -6, going all the way to negative infinity. So if it's going to negative infinity, if I read left to right, I go from negative infinity to -3. What kind of bracket? It's an open dot, so it would be what kind of bracket? Soft. Okay? What do we think? Am I doing okay? All right. Let's see. You don't have that, so I'll move off that. Okay. At the very top of yours, you have something that says okay. If you multiply or divide and you had a negative number in front of the letter, still with me on this? If you multiply or divide and you had a negative number in front of the letter, the inequality sign flips over. Okay? So it doesn't flip over because the equation had the x on the right side. If you multiply or divide to get a number by itself, so on this one, if I divided both sides by -9, and I know this isn't on your thing, but maybe you can squeeze in that little blank, those cancel, but the sign is going to flip over because this negative. That negative makes the sign flip over because we had to multiply or divide by a negative to get the letter by itself. Okay? If you had something like this, let's take the same kind of problem. Well, let's say it's that. I'm dividing both sides by 9, agreed? So whatever I moved, in this case, this sign does not flip over. It doesn't flip over because I did not divide by a negative to switch it over. So if a number is negative already, if my dividing or my multiplying thing was not a negative to move it over, the sign doesn't flip. So there's a big difference between the two. Okay? So let's explore a little further. I think these are your last couple problems. Is that right? Okay. So for problem number 6, what do you think I have to do to both sides to get y all by itself? Divide by -4. If I divide by a negative, what's going to happen? The sign's going to flip. So I'm going to get y, sign flips over. And then what's 16 divided by -4? -4. So on a number line, if we had a 0 here and a -4 here, is it an open or a closed dot? Closed. Why is it closed? Yeah, you have an equal, so it's going to be closed. I want values that are less than or equal to -4. So like -3, -2, -1. So it's going this direction. Where that direction is going where? Negative infinity. We read the number line from left to right. So negative infinity to -4. What kind of bracket at the end? Closed, which is a hard bracket. Yes, square bracket. Hard bracket. Huh. So things to note. How that sign flipped over. Why did it flip over? Because when I got the letter, the variable by itself, I had to multiply or divide by a negative number. Okay, problem number 7. Let's distribute over these. Is that a +6 or a -6? Plus, because negative times negative, right? Those are like terms. 6 and 1 are like terms. What's next? Okay, after that, subtract 7 from 11. Good. So that's going to give me negative 2x is greater than 11 minus 7, 4. Is that right? What's the last step? Divide by negative 2. Being I divided by a negative, what's the sign going to do? It's going to flip over. 4 divided by negative 2 is how much? Negative 2. And I kind of ran out of space over here. Is it an open dot or a closed dot on the negative 2? Open, because I don't have an equal sign. I want values that are less than negative 2, so like negative 3, negative 4, negative 5. So I'm going to the left. Where is this pointing to? Negative infinity. In order to get to the interval notation, I'm going to write it based from left to right. Negative infinity always has a soft bracket. Negative 2, soft or hard bracket? Soft. Why is that? No equal sign. Open dot. Both reasons are totally appropriate to say. Woo! Look at number 8. Well, I'll just pause for a second and figure out this number 8 here in a sec. We have the fractions, don't we? So some thoughts. What should we multiply all 4 items by to get those fractions by? Go ahead. 6 won't get rid of. Go ahead.
21 over 1.
Yes, good. 21 over 1, or if it's a whole number, just by 21. Yeah. Okay, 7 goes into 21. Agree? And 3 also goes into 21. So 21 is the smallest number that both 7 and 21 share that they both go into. And I have to multiply 21 over 1 to every term there. Okay, so I'm going to move this down a little bit so we can see it. All right, and let's do this. I think I can go with this, that. So I'm going to multiply this by 21 over 1, 21 over 1, 21 over 1, and 21 over 1. Agree? So 7 goes into 21 how many times? 3. 3 times x is 3x. Subtraction sign comes along. 3 goes into 21 how many times? 7. 7 times 2x is 14x. Good. Subtraction sign comes along. 7 goes into 21 how many times? 3. 3 times 1 is? 3 is less than or equal to. Sign stays as is. 7 goes into 21 how many times? 3 times 10 is? 30. Okay, let's just pause there for a minute. Do you agree with the math that we just did? Make sense? Okay. I think I have some like terms on the left side. What do you think are the like terms? Yeah, 3x minus 14x. Those are both like terms. So let's go ahead and combine those together. 3x minus 14x is negative 11x. Very good. Minus 3 is less than or equal to 30. What we do to one side of the inequality sign, we have to do to the other. So I'm going to add 3 to both sides. So those cancel. So I get negative 11x on the left is less than or equal to 3 plus 30, 33. Last step. Divide by negative 11. Being I'm divided by negative 11, what's going to happen to this? Okay, so these reduce out. X, flip over the sign. 33 divided by negative 11 is? Negative 3. So there's our inequality. We could graph that. Negative 3, I got 0 here. Am I going to the right or to the left when I shade it? Right. Solid dot or open dot? Solid, because I have an equal sign involved. So I have a solid dot here. I'm going to the right here. And that right's going where? Infinity. Now to write the interval notation, we read it from left to right like we would read a book. So -3, hard bracket or soft bracket on the -3? Hard bracket because we have an equal sign. We also have a solid dot, comma, infinity, hard or soft bracket on infinity? Soft. Okay. Wowzers. Good stuff. All right. So I'd like you to do page 71 and 72. I'm going to give you some time to start it. And we're going to do all of them if that's okay. And I'm going to stop recording now if that's okay.